Hi and welcome to MSc. In this video we're going to be looking at both the names and formulas of molecular compounds. Now molecular compounds form when nonmetals share valence electrons in order to mimic having a full valence orbital. This leads to a covalent bond. But due to the sharing of electrons, nonmetals can actually bond in a variety of ways. Remember, this is different than ionic compounds that always bonded in fixed ratios. Right? If I had sodium, which is a metal, and chlorine, which is a nonmetal, it's always a 1-to-1 ratio. The sodium is always just going to give its one electron to the chlorine. Chlorine wants one, and that's it. But with the sharing, we can have a variety of different ways to share the electrons. And so subscripts are going to matter. This means that our ionic naming convention isn't going to work for molecular compounds. Remember, in the ionic naming convention, unless there's transition metals, we don't really worry about the subscripts on the elements in the compound in our name. That's not going to work anymore. So with molecular compounds, we use a prefix system in order to identify the ratio of atoms present in the compound. So we have to know the prefix system. If there's only one atom in the compound, like has a subscript of 1 that we don't write, the prefix is mono. If there's 2 atoms of that element, it's di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa. Now sometimes we'll end there depending on the course. I think it doesn't hurt to know the prefixes all the way up to 8 or 10, so we'll go a few more here. 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. Some teachers will have you memorize these. Some might allow you to have a sheet with this written on it. I personally think that memorizing these prefixes, especially up to the first 6, 8, or 10, is a reasonable thing. And some of these you know already from other situations. Penta, like pentagon, hexagon, octagon. So there's some built in here that aren't as bad, right? Triangle, for example, is 3. There's rules, though, that we need to follow on top of using the prefixes. So remember, first and foremost, that the prefix here matches the subscript, and we'll see this through a couple examples I'll do on the next slide. The second element still gets that IDE or IDE ending that we're used to from ionic compounds. And the last one here for us right now is that the prefix of mono is not used on the first element. So the molecular compound name is not going to start with mono. So here's a few examples for us to take a look at. And we can see we have phosphorus and sulfur. So I have 2 of the phosphorus, which means it's going to be diphosphorus. And I don't change the ending on this one because it's not the second element. It's just diphosphorus. Again, this 2 here from my chart led me to the di prefix. And prefix is something that goes at the start of the name. A suffix is something that goes at the end. So it's diphosphorus. Then the sulfur is the second element, and there's 3 of them. So that's going to lead to trisulfide, and we still use that IDE ending on the second element. So we have 3, which is tri, and I keep the IDE ending on the second element. Now here we have nitrogen and oxygen. There's only 1 nitrogen, so you might think, oh, mono's 1, so it'd be mononitrogen, but it's the first element, so we just put down nitrogen. And then there's 2 of the oxygens, so this becomes dioxide. So again, there's no number here, which is why there's nothing here, because we don't put mono on the first. There's 2 here, so we get di, and then we end with the ide. Moving along here, we have another example where we have sulfur and bromine. There's only 1 sulfur, so it's just going to be sulfur. And there's 2 of the bromine, so it's going to be dibromide. So again, things we're looking for is the lack of prefix on the first one, 2 here, and the IDE ending. Here again we see sulfur, so we're not going to overcomplicate this. We're just going to say it's sulfur. And here I have 6, and that was the hexa. and it's fluoride. So again, the 6 leads to the hexaide, and the fact that there's nothing written there leads to nothing at the front of the sulfur hexafluoride. So that's how we name molecular compounds using the prefix method. Obviously, I didn't use all the prefixes in these examples, but as long as you're comfortable putting the prefixes on the right spot, this in many ways is easier than applying the zero-sum rule or dealing with transition metals. When we go to find the formulas of molecular compounds, I often find that students find this part easy as well. The prefix just simply tells us the subscript. And again, we don't have to worry about zero-sum rules or crisscross or reducing here. In fact, we're not supposed to reduce the subscripts, even if we can, because we have different ratios that are possible. So we shouldn't reduce to the simplest. So let's work through this one. We know we have nitrogen. I'll put down nitrogen. I see the chloride, which tells me it's chlorine. The mono, which we don't write on the nitrogen, tells me there's only one, which I won't write. And the tri here tells me that there's 3. Right, so this tri is that part right there. On the next example, we have carbon and we have oxygen. So CO. Again, there's no prefix on the carbon, so it'll just be 1. And the di prefix here tells me there's 2. This is CO2. Right? And again, generally students find this easy. The trick here is not trying to crisscross, not bringing this tri over to the nitrogen or doing anything like that. It's attached to the chlorine. It goes with the chlorine. I hope this quick run through of molecular compounds, naming, and formulas has been helpful. If it has, please consider liking the video and subscribing to the station. And as always, thank you so much for listening and watching.